Hello and welcome to the second Generative AI video. Today we're going to be talking about machine learning a little bit, and we're going to be doing it from kind of a high level perspective since um, I'm not smart enough, and it also really isn't necessary for all of us to necessarily go super into detail on the math of all of it, which is super amazing. But we're going to just try to kind of do a high level overview, and it's important to know a little bit about it, about how these AIs work. Since we're using them so often. So just having that kind of background knowledge so when people talk about it, we can understand and follow. It's just something that's good to have in your back pocket. So we're going to start with kind of the general machine learning pipeline. It's going to start with collecting data. So you want to gather relevant examples so that way your model can learn meaningful patterns from real situations. So if you're doing a more so specialized model, you might want to give data relating to that. Or maybe for some of the general models like what ChatGPT is doing, like OpenAI will get all these big research articles and anything that has long text, and they'll just feed it to their model, and then they'll train the model, and the algorithm is studying the data and tweaking parameters to recognize patterns automatically. So a really nice example that I found to kind of help you understand how this works is it's like if you're kind of controlling a big soundboard like a DJ or whatever, and you're tweaking all the little knobs just to make sure the output of the sound you're getting is just right and what you want. You can't do it all at once and just get it first try, but it takes a little bit of moving everything around. And then so you kind of validate and test your accuracy, and you need to give new data, which is key, not your old data. And then if your model is working with new data that it's never seen before, that's good, and it's able to start making predictions. And that trained model is able to process these new inputs and then start generating decisions in real time. And then kind of you can iterate on that and improve and repeat it, so your model becomes better over time. So we're going to talk about a little bit about training versus inference. These are kind of the two sides to it. When you're training your model, that's kind of the big setup process where you have the model studying the large data sets in order to find the patterns and the relationships. And then those parameters being adjusted are like those knobs I mentioned earlier. Um, so training requires significant computing power and time because for each of those little knob adjustments, it's having to do more math. And that's why you have all these companies building massive data centers with the GPUs and now even the TPUs, um, because they want their models to be as good as possible and trained on as much data and accurate as possible. So that's a really time consuming and expensive process. Inference is kind of what we see. It's the trained model when we give it new data that's never seen before, and then it's able to take that new data, our input text or whatever, and it's able to generate those predictions and decisions. Um, so that process happens in real time. You can do it locally on a PC or something. You can also do it in the cloud. It's kind of how your phone is connecting to ChatGPT or whatever. And that's how like chatbots, basic recommendation engines, voice assistants, things like that are all powered. And the answer time depends on a few things. So the model size, how many parameters it has, how many knobs, the hardware strength if you're kind of running it locally, and also how much data you ask it to process. So if you give it a massive PDF, it's going to be like, take a second to read that compared to just saying, hey, what do you think about X? And then lastly, we've talked about giving the model data a few times now. So why does that data kind of, what's the deal with it? You need to make sure your data quality is really excellent since the input that you give it is going to be the output, right? And if you give it garbage, it's going to put out garbage. So that's the current reality where you kind of have these machines that they don't know anything themselves. Their entire function is completely based on historical data and finding those patterns. And the problem is if you give data that's incomplete, doesn't cover something, it's really biased, or it's just kind of low quality, maybe inaccurate sometimes, the AI is not going to have a way to realistically understand it. And it's going to have that low quality kind of built into it or have those biases built into it. So when your predictions come out, it will be just like the data. So the solution is to make sure your data is clean and it's representative of what you want your model to do. And it's also diverse from a bunch of different areas so the model can kind of generalize better and be able to predict lots of different things no matter what the input is. And you want trustworthy results. You don't want to have a model that's all biased, or that gets things wrong sometimes because you gave bad data. And bad data can really be a hindrance. So it's better to give no data at all, like if you're just adding a little bit more, than bad data. So that's kind of a quick high-level overview of machine learning. Thank you very much for watching. If you have any questions, email the club, come to the meetings and ask us, and we'd be happy to answer. Thank you.